Now we're going to look at taking the derivative of a natural exponential. And of course you've got two rules here. The first one, you're asked to take the derivative with respect to x of e to the x, which is just going to be e to the x. Now, if you happen to have something else in your exponent besides just x, that's what your u represents, is something else. So kind of like with natural log, if you really remember this one kind of covers this one at the same time. So what you're going to do is basically just write this down just like it is. So if this is e to the u, then you're going to write down e to the u, and then what you're doing is applying chain rule, and then you're multiplying by the derivative of u, which is thought of as that inside function, you know, that we talked about whenever we would talk about chain rule. It's just back up here on this first one, if I were to apply this rule here, and I were to multiply by the derivative of my exponent, see, that's just a 1, so which is still just going to give me e to the x. So anytime it's e to the x, the derivative is just e to the x. But then don't forget to multiply by the derivative of whatever your exponent is. Okay, first one here. So we have e to the 6x plus 1. So that would have to be e to the 6x plus 1. So that's e to the u times u prime. So if this is u, you need the derivative of this. Of course, the derivative of 6x is just 6. Of course, derivative of 1 is just 0. So you just end up with 6 times e to the 6x plus 1. That's going to be your derivative. All right, on the second one, I would suggest that you take a step here and rewrite your exponent by bringing the x from your denominator to your numerator. That way you don't have to worry about quotient rule. So I haven't done anything with my derivative. I'm just simply rewriting my problem. So now when I go to take derivative, that's going to be e to the u times u prime. So I need to take the derivative of this, which is just going to be power rule. So you do your power times your constant multiple here. So that's going to give me positive 3 times x to 1 less power. Now you'll need to rewrite a couple of things here. You will need to take x to the negative 1 back to the denominator. Now, it's not going back to the denominator of this whole thing. Remember, this is all in the exponent, so it's just going to give you a fractional exponent, okay, just like it was in the beginning. Now, this one needs to go back to the whole bottom. So you're still going to have the 3 on the top, and you'll still have e to the negative 3 divided by x, because you're taking this negative 1 back to the bottom, but then all of this is divided by x squared. So the x to the negative 2's got to come to the bottom. Okay, next one. Now this one's going to require that you use your product rule, because you've got x squared times e to the negative x. So using your product rule, you'll have first function, derivative of second. So e to the negative x. So this is going to be e to the negative x times negative 1. That's e to the u times u. Plus second function times the derivative of the first function. Now you've got some common terms here. I'll tell you what, let's rewrite. Let me do one more step before we start talking about a common factor. If you multiply all this together, you could just write this as negative x squared e to the negative x plus, and this would be 2x times e to the negative x. So you do have an x in common, and you also have an e to the negative x in common. So that's just a greatest common factor. So that would leave me here with a negative x and here with a positive 2. Of course, if the answer, like if you're checking your answer, they may have this written even as 2 minus x, or it could be they may have even taken out a negative and have a negative sign out here. So a couple of different options when that's with that with that answer. All right, number 4. Now, I would take a step here of rewriting this one. If you leave it like it is, you're going to have to use quotient rule, but this being just a constant, I would just pull that constant out front as 1/3. Okay, so now starting the derivative, this 1/3, remember, is just a constant multiple, so you're taking the derivative here. So you take the derivative of those two terms individually. So e to the u times u prime plus e to the u times u prime. Of course, multiply these two together, so that would just be 2 times e to the 2x. And we can just change this to minus e to the negative x. Now, if you want to distribute the 1/3, you can, or it may be that you come back and say all of this divided by 3. So again, a couple of options there on your answers. Okay, now this one's going to require quotient rule. It's just as you do your quotient rule, a portion of it, as you can see here, is your e. All right, so using your quotient rule, we'll have low d high minus high d low. Now when you take the derivative of the bottom, of course the derivative of 1 is just 0. So now we need to take the derivative of this term. So this will be e to the u times u prime. And this is all divided by 1 plus e to the 2x squared. Okay, you actually don't have any common factors here, just kind of writing it a little bit neater. So I'm just going to say that I have the cosine x times 1 plus e to the 2x minus 2e to the 2x times sine x. Okay, now, I mean, it doesn't matter which of these two you write first. I mean, that's multiplication, same thing here. It doesn't matter which of these two things you write first. It's all multiplication. And that's all divided by 1 plus e to the 2x squared. Now, if you could factor something out, you know, and possibly cancel with something in the bottom, you would, but there's not anything on this example to do that with. All right, the next one.